These are your last set of notes for Unit 6. This is your second to last unit in this semester. So we only have one more unit after this, which is awesome. So what I like about 6.5 is that it's a lot faster than what you did in 6.4. 6.4, there was a lot of calculations to do. In 6.5, your first 4 questions you're going to have to graphing images. They have only made it difficult because sometimes you're going to have to deal with fractions. A lot of them, you're going to have decimals in a graph. They did that because you're in high school and that they think you can do it. You may not like to do it, to go 4.5 and left 1.5 and figure out a spot, but that's what's going to happen. Okay, we'll talk about that. They're also going to ask you if it's an enlargement or a reduction, and they're going to give you fractions to see if you get confused easily. For example, if they have a 7/6 is the scale factor, my biggest hint to you is look and see what's bigger. If the top is bigger, it's going to be greater than 1. It's going to be an enlargement. If the bottom is bigger, it's going to be less than 1. It's a reduction. That might help you when you get there. The other thing is that there's going to be a rule that's given. They're going to tell you you have these X's and Y's, and what you're doing to all of your X's and Y's is you're doing 1/4 of the distance in the X direction and 1/4 of the distance in the Y direction. What that means is the scale factor is 1/4. It means that instead of you making it 4 times as big, you're making it 1/4 of the size. It makes it a reduction. It's smaller. And this is mathematically how you write it. Your X's and your Y's, this is 1/4 of your horizontal distance and 1/4 of the vertical distance. It makes it similar, proportional, by the way. And this only works for dilation centered at 0, 0. I need to say that for the record. So let's get to some examples. I have 4 examples picked out for you. This is number 3 on your worksheet. If you have your worksheet, open it up. You have to determine if it's a reduction or enlargement. Here's a dilation of 3/2. Is that a enlargement or a reduction? If you said enlargement, you are right. 3 divided by 2 is the same thing as 1.5. It's going to get bigger. Then we have to graph the image. So this is the hardest part, is that there's going to be decimals. I'm going to recommend you look where this Y is, go follow it down until you find the X and where they cross, and put a dot where the origin is. Where is 0, 0? Put a dot there, label it O. O stands for origin or origin, depending where you come from. From this origin, from this point, if I need to do a dilation of 3/2, I have to go horizontally 2 units to the right and 1 unit up. You are going to have to think, what is 2 times 1.5 and what is 1 times 1.5? In the horizontal direction, we went 2, then up 1, but I needed to have that 3/2 bigger. 2 times, if you need a calculator, use a calculator. We're going to go 3 to the right. 1, 2, 3. We're going to go 1.5 times up. 1.5. G prime is right here, halfway between 1 and 2. They say, oh, you're in high school, you can handle a decimal in graphing. A lot of you, you're not going to like it. But just do it. It's fine. Let me say this way. I told this the second period. Nobody dressed up as a fraction on Halloween because they're not really scary. Or nobody's ever thought of that, right? Fractions aren't scary. Don't be scared of them. Otherwise, people would dress up as them for Halloween. You don't see any fractions walking down the street, do you? Just saying. Think about it. What about the distance from O to B? I go to the left 2, down 2. I need to multiply that by 1.5. So instead of me going to the left 2 and down 2, I'm going to go to the left 3 and down 3. That's where B prime is. I'm going to count to P. To the left 1, up 3. I haven't done 3 times 1.5 yet. That's 4.5. To the left 1, instead of 1, I'm going to go 1.5. Whoever's next, you can go. Instead of going to the left 1, I'm going to go to the left 1.5. And instead of going up 3, I'm going up 4.5. 1, 2, 3, 4.5. I know that looks funny. We have a spot right in the middle of a box, but that's where negative 1.5 is and positive 4.5 is. That is the point P prime. Ideally, we have that spot. We have that spot. That didn't come out very straight at all, did it? And if you do it right and you actually connect these dots, it should end up making a triangle that's exactly the same shape as what we had before, just 1.5 times bigger. These angles are going to be congruent and the sides are proportional. Don't freak out if you have a decimal. This is number 6. Number 6 says, write a rule to describe each dilation. Now you can choose whichever one you want to use. As long as you remember image divided by pre-image, you can figure out the scale factor. First thing we have to do is come up with a rule. The rule is what goes here, what goes here. We wrote that down in our notes. We're going to change all of our x's and y's. Not just the first x and we're changing every single one at all 3 corners or all 4 corners. And the primes mean that this shape got bigger. So it's definitely it has something to do with like getting bigger. How much bigger? We're going to have to figure that out. And it doesn't matter what you choose, whether you choose horizontal or vertical. I'm going to choose point V this time, and it doesn't matter. I'm going image. Oh, that one doesn't come out nice. And let me see if I can get which one of these is on the line. Let's go here. 1, 2, 3. I'm going to go to point A. How far to the left did I go? I went to the left 3 units. How far up did I go? I went 1.5. This is horizontal. This is vertical. For the pre-image, how far left did I go? I went 2 units horizontally. How far did I go vertically? I went 1 unit. So if I want to know what the scale factor is, I go horizontal of the image, vertical of the image, 3 divided by 2, or even 1.5 divided by 1. Let me show you what that looks like. 1.5 divided by 1 is still 3. 3 over 2. What does that mean? That means that this is 3 over 2. That's the same scale factor. What are we doing to our x? We're multiplying the x's by 3 over 2. We're multiplying the y's by 3 over 2. That's how we write the rule. It's our second example. And I only chose this one, but if I were to choose any of the other points, you would get the exact same answer. I have 2 more examples, and then I'll give you the rest of the time. Determine the scale factor will reduce or enlarge the figure. A dilation of 2, does that reduce or does it enlarge? I agree. Find the coordinates of the vertices of each figure after the given dilation. If point W is to the left 2 down 1, then horizontally it goes left 2 down 1. If we need to double that, we could find the new point by just multiplying. It would be, instead of left 2 down 1, it'd be left 4 down 2. A dilation of 2 is basically taking this point and timesing by 2 and timesing by 2. You could do that to figure out any of those points. E would be at -4, 2, and I bet you could do J and X on your own. The last example is number 12. The way that they show you how to do this is they say, hey, look, this is what the rule is for these coordinates. And they give you a bunch of coordinates. I'm trying to think if there's anybody who's next. You can go. They give you a bunch of coordinates, and then they say, here's the rule that everything is being applied by. It's okay. Birthday girl. All that they're really doing is they're checking their image divided by the pre-image. Matter of fact, I know these are the images because they have the little apostrophes of the primes. This divided by that is 1/4. This divided by that is 1/4. This divided by that is 1/4. And it doesn't matter if it's a negative divided by a negative, that makes it a positive, or vice versa. It's always 1/4 of x and 1/4 of y. For us, you're going to take the image divided by the pre-image. Negative divided by a negative is a positive. And it should be the same thing for each x and for each y. What number, what's the scale factor that you get every single time for number 12? If you know it, say it. I heard 3 to 1, but I'm just going to put 3. 3x, 3y. I'm hoping that makes sense to you. I'm going to stop your notes right there.